Hello and welcome back to part 2 of our discussion of the EOQ with quantity discounts. In the first video, we talked about the all units quantity discount schedule, which assumes that the quantity discount applies to the entire quantity to all units in our orders. So if, for example, we were to place an order for 500 units, looking at this schedule right here, we would assume that we will pay $9 for each of those 500 units in our order. Now, if we conversely assumed an incremental quantity discount schedule, we would have to pay $10 per unit for the first 399 units in our order of 500 units, and the discount of $1 per unit would apply for all those units that are in excess of 399 units. Or more specifically, we would have to pay 399 times $10 plus 100 times $9. So there will be a difference in acquisition costs and in average unit costs that will, of course, also affect our optimal order quantity and our inventory decision making. So what I want to show you in this video is how we can take this difference in quantity discount schemes into account as we calculate optimal cost minimizing order quantities. So what we see here in this lower portion of our worksheet is a total cost function that takes this adjustment into account. You see that this total cost function differs from our standard total cost function in that we have these D sub I divided by Q adjustments that are also reflected in the EOQ formula. Well, this D sub I, as it turns out, simply represents the additional acquisition costs that we must take into account because we are dealing with incremental quantity discounts rather than all unit quantity discounts. So it is the cost that we have to pay extra for those quantity increments for which the quantity discount does not apply. Now, as we try to find the optimal order quantity, we will set up a table like this, where we will start with the highest price break and then work our way down to the lowest, and of course most desirable unit price. So the first thing we need to do to solve this problem is we need to calculate the value of D sub I. Now if we look at a unit cost of $10, what is the extra cost we incur because this unit cost of $10 does not apply to the entire order quantity? Now clearly, as you can see, this is the highest cost and it applies for any order quantity. So regardless of whether I order $10 or 200 or 300 units, I will get this price, this $10 price for all units in my order quantity. So D sub I will always be 0 in the highest quantity bracket, or I should say in the lowest quantity bracket at the highest unit cost. So moving on to the next increment where we have a unit cost of $9 that applies for all incremental quantities between 400 and 1,199 units in my order. Well, I simply realize that for the first 399 units, I will not get this price. Rather, for the first 399 units, I will have to pay an extra $1 per unit. And this is exactly what D sub I represents. In this case, it represents $399 of additional acquisition costs, because I know that the quantity discount of $9 does not apply to the first 399 units in this order. And that is exactly what this formula right here tells me. We can simply implement this here. U sub j is simply that quantity discount break, or in this case 400 units minus 1 times. Now this is simply the difference between the higher price and the price we are currently looking at. So the higher price will be $10 in this case minus now the discounted price of $9. And you can see that we are looking at this $399 that we mentioned. So what we are going to do is we are going to calculate D sub I for the other price breaks as well. And again, we simply realize that as we talk about a unit price of $850, we will definitely have to pay more for all of the first 399 units as we just calculated. Plus, now we take into account that we only get $850 per unit for any increment quantity beyond 1,200 units minus 1 again, times the difference in the next higher price, in this case of $9 minus this discounted price of $850. And you'll see that now we're looking at a total additional acquisition cost of $998.50. And likewise, as we look at a unit cost of $8, we realize that we will deal with the additional acquisition cost that we calculated of $998.50 plus another incremental cost that we incur because we got this reduced cost only for an increment beyond 4,800 units minus 1 times the difference from the next higher cost of $8.50 minus $8. So we are looking at a value of D sub I of $3,398. Well, now having calculated that, we can calculate the EOQ using this formula here. This formula was simply obtained by minimizing this expression over this vector Q. So let's do that. We'll start again with the highest price break. So the EOQ will be the square root 2 times lambda times K, and of course D sub I is 0 in this case, so we simply divide all this by our inventory holding cost per unit per year, which is C of $10 in this case, times I of 25%. That gives me an EOQ of 392 units. Of course, you'll see that we have calculated this before up here. This is just the basic standard EOQ without any discounts. Now we will calculate the other EOQs for the respective price breaks. So we are looking at $9, for example. The EOQ will be the square root of 2 times lambda plus K. The EOQ will be the square root of 2 times lambda times K plus the value of D sub I, in this case divided by the unit cost of I times 25%. And that will give me an order quantity of 1,369 units roughly. And we'll do the same for the next price break, which is the square root of 2 times lambda times K plus the quantity discount I need to take into account. Divide that by C times I. So this yields an order quantity of 2,166. And then finally we'll do that for the highest, for the best price break as well. The EOQ in this case will be the square root of 2 times lambda times K plus the extra discount cost. Again, the cost that we incur because we do not get the discount on the entire order quantity. And we divide that by C times I for an order quantity of 4,062 units. Now next we want to ask ourselves, are these EOQs what we just computed actually valid? And what we mean by that is, do we actually pay this price if we order this quantity? Well, clearly if I order about 392 units, as you can see, yes, I'll pay a unit price of $10. So we know that this particular EOQ is valid, and we will simply say yes right here. Looking at the next one, if we were to order about 1,369 units, would I pay a unit price of $9? Well, clearly if we take a look at this, you'll see that if I order 1,369 units, I will actually pay $8.50 rather than $9. So this EOQ is not valid, because if this is what I order, I'll pay a different price. Finally, if I order 2,166 units, is this the price I will pay? The best price I will pay, $8.50. Yes, clearly, this EOQ falls in the respective quantity increment between 1,200 and 4,799 units. So this is a valid EOQ. And then finally, do I get a price of $8 per unit if I order 4,062 units? And clearly you can see that no, this is not the case, because I would have to order at least 4,800 units. So again, this EOQ would not be valid. Now, as you see, we end up having two scenarios with valid EOQs. An EOQ of 392 and an EOQ of 2,166. Now, what we will simply have to do is we will have to calculate the total cost associated with each of these valid solutions and then simply choose the lowest cost outcome. Now, I know that the total cost will be, if I order 392 units, we have already calculated that up here when we talked about the all units discount, quantity discounts. And we found that in this case, the total cost, the sum of acquisition, inventory holding, and ordering cost would be about $48,980. Now what I want to do is I want to calculate the total cost associated with the other valid solution with an EOQ of 2,166. And I will simply implement the formula that is shown right here. So the total cost will be the sum of, now in parentheses, the unit cost, in this case $8.50, plus our quantity discount adjustment of $998.50, divided by the relevant ordered quantity times lambda. and these would be my total acquisition cost. And I will add to that the inventory holding cost calculated as Q divided by 2 times the relevant unit costs, plus my extra costs because we have an incremental quantity discount. And we will multiply all that with the inventory holding cost factor, I. And finally, we add to that our order placement costs, which are simply equal to lambda divided by Q times K. So you see that now I obtain the total cost figure of $45,528. Now clearly this number is lower than the other option of the EOQ of 392 units. So clearly it is more desirable, meaning a lower cost solution to order 2,166 units at a time. This is how I will minimize my total sum of acquisition, inventory holding, and placement costs. Now note, of course, that this optimal EOQ of 2,166 is fundamentally different from the optimal solution that we found when we talked about all unit quantity discounts. So you see that we have to be careful in distinguishing between these two different quantity discount schemes, because depending on what kind of quantity discount schedule we have in effect, we will make very different ordering and inventory decisions. I hope this brief discussion helps you understand the difference between these quantity discount schemes and helps you understand how we can factor these quantity discounts into our inventory decision making. As always, please be sure to let me know if you have any questions, and also remember to take a look at the textbooks which will further discuss these issues we briefly reviewed here.